Alright, so this is Avogadro's gas law, and this is one of the 4 basic laws that we will use the ideal gas law with. Now, you've already done the ideal gas law PowerPoint, so you should be able to apply it as we move into Avogadro's law, okay? Alright, so Avogadro's law basically shows us the idea that says when you add gas to a container, if the container has a non-rigid sides, the volume will increase. Now, you guys saw this when we blew up the balloon in that small little demo. You can blow up your own balloon, you can blow bubbles, you can do all sorts of things that you understand that when you add a gas to something, the container will expand, all right? So in this particular case, Avogadro is always dealing with the mole. I mean, he's all about the mole. And so Avogadro is volume and moles. And a lot of you guys are going to remember that Avogadro sounds like avocado. And so you can consider that he's all about the guacamole. Just a stupid little joke. But if you have to remember something, this is the only one. Avogadro is the only gas law that deals with moles. Alright, so just reviewing the ideal gas law, we know that every one of the basic laws, Avogadro's included, can be found, the relationship can be found within the ideal gas law. I'm not going to review this anymore because, again, hopefully you understand PIV NERT, pressure times volume equals N, which is number of moles, the gas law constant R, and T is temperature in Kelvin. Alright, so this is just a really quick little video animation that what you see with regard to Avogadro's law. You can see the gas source is that column in blue, and you can see the gas is being pumped into the container. You see the yellow center area, and that it's getting more and more dots in it, which means the number of gas molecules are increasing. You can see that pressure, which is the little green weights on the top, stays the same, and you can see that temperature down in the lower right corner, it also stays the same. So the only 2 things that are changing here are going to be the number of moles of gas, which is measured in mass, and the volume. And you can see the relationship that as mass increases, volume increases. It's just a really easy way of being able to see Avogadro's law. Now, Avogadro's law, the other thing you remember is when the letters are on opposite sides of an equal sign, PV equals nRT, the V is on the left, the N is on the right, that you know you're going to have a direct relationship. When one goes up, the other one goes up. All right? Okay. So here's the problem. Again, Avogadro's law, let's just show you how it separates out into become, there's the ideal gas law. Now let me show you how it becomes Avogadro's law, because everything else, temperature, pressure, are constant. So they are given the letter K, which means it doesn't change. And when we do this, we understand then the relationship. And it should make sense because, again, you know, if your lungs expand when you breathe in, why do they do that? Because they're getting more air inside. All right, so I've got a couple practice problems. I'm just going to read through them for you, and then I'll work them over here to the left really fast. We've got 3 balloons with different amounts of gas. The middle one, we understand the red one has 3 moles of gas, and it's 30 liters. So this would be N, and this is V. And when we're looking at the green balloon, and you can't see that very well, we understand that there are 2 moles, which is your N. We do not know what the volume is. And then on the right, we have the blue balloon, and we know that it has 45 liters, but we don't know how many moles there are. So since we know most about red, we're going to always call red number 1 for the problems. Okay, so red is going to be number 1. So when we look at the law, we know that the law for Avogadro is V1 divided by N1 equals V2 divided by N2. So what we're going to do for this first problem, because we're trying to find out what V2 is, this is a 1, that is a 2, we're going to put 30 liters over 3 moles. That's your V1 and your N1. And we're going to set that equal to, we don't know how many liters, over 2 moles. Now you can cross multiply, you can rearrange. It really doesn't matter to me. I cross multiply. I'm going to multiply 30 liters by 2 moles. I'm then going to divide by 3 moles. Why? My moles cancel. And I'm going to have the number of liters over here. So I have 30 times 2 divided by 3, which means I have 60 liters divided by 3, which means my answer is going to be 20 liters. Okay? You'd expect this because, again, what you're looking at here is less gas should have a smaller volume. We had 3 moles in the red, we only had 2 in the green, so you would expect there to be a lower volume. Alright, so let's move to the other problem. We are still using red as our V1, N1, but in this particular case we're trying to solve for N2. Alright, so we're going to do the same thing here. We're going to say red is V1, here's N1, is 30 liters divided by 3 moles is equal to 45 liters and question mark N2. Again, you are more than welcome to rearrange this using algebra. I'm not a fan of having to do that, so I'm going to cross multiply. So I'm going to take 30 moles times 45 liters. I'm then going to divide by 30 liters, and I'm going to then know that that equals N2. Multiply, divide, equals. That's how I've always done this, and it works really, really well. Liters cancels. So what we end up with here is 135 moles, because the liters has canceled, divided by 30. Alright, and that should be 4.5 moles. Again, I will let you do your math the way you need to, but you have both practice problems, and please know that if you have any questions, you can give me, send me an email. Alright? Alright, so of all the gas, we have all the gas laws, and you can again see here at the top, you see PV equals nRT. There's your basic ideal gas law. You can see that since Avogadro's number is V and N, everything else, the P, the R, and the T become a constant, K. And so you understand that, again, V is on the left, N is on the right. So what we're going to end up with is V1 over N1. And then for your second set, it's V2 over N2. All right? Down at the bottom of here, you will also see how you can isolate K, and you get that same equation. All right, so the only other thing I want to do really fast, and I want to try to get this done in about 30 seconds, is, each one of these laws, there are weird ways of being able to remember them. I've already kind of done this one, and the idea is, here's the clue, Avogadro's law is a relationship between volume and moles. We know, since his name sounds like avocado, we're going to pay attention to that V. V is for volume. All right, and then you can remember that he's all about the volume and the guacamoles, because avocados are all about guacamole. So use that as you can to help you remember Avogadro's law, and I will be talking to you with Boyle's law coming next.